Okay, let's see question number 2 now. So question number 2 is what? Let x1 x2 up to x100 be IID normal 0 1 random variables. The correlation between summation xi from 1 to 98 and summation xi from 3 to 100 is equal to. So we need correlation coefficient between this. So what is the formula for correlation coefficient? This is covariance xy. So if I call the first one as x and second one as y, so correlation between x and y as correlation coefficient between x and y is covariance xy upon variance x square root and variance y square root. Okay, so variance, since all xi's are, so let's change the tab. Yeah, since all x1 x2 x100 are id random variable normal 0 1, so each xi has mean 0 variance 1. So let's call this x, let's call this y. Okay, so we need variance x. So variance of x is what? It is 1 to 98. So when we calculate, so it's a variance of x1 plus variance of x2 up to variance of 98. So each has variance 1. So 1 plus 1 plus 1 up to 98. So it's a 98. Similarly, variance of y we need. So it's a I starts with 3. So x3 plus x4 plus x5 up to x100. So we need variance of y. So variance of y is variance of x3 plus variance of x4 up to variance of x100. So that is again 98 terms. So it will be 1 plus 1 plus 1 up to 98. So it's a 1 added to 98 terms, it's 98. So variance x we got, variance y we got. So we need covariance of xy because correlation coefficient is covariance xy upon sigma square x and sigma square of y. The variance x square root, variance y square root. So we need covariance xy. Now covariance of xy. So covariance of x is we have summation xi from 1 to 98, comma summation xi from 3 to 100. Okay, so let's expand this. So we need covariance of, this is x1 x2 x3 up to x98, comma this is x3 and x4 up to x100. So if we open this from the formula of covariance, it is covariance of x1 comma x3, one term from one term here, then covariance of x1 comma x4, and like that it will go like covariance of x1 comma x100. So I have taken each term of this with x1 and covariance x1 x3 plus covariance x1 x4 and so on, covariance of x1 x100 plus similarly covariance of x2 x3, and like it will go till covariance of x2 x100. So it will keep going. So at last the last term will be covariance of x98 comma x100. Now we need to see there are 98 into 98 terms in all. So we have to consider what? So since we know x1 x2 all are IID, independent and identically distributed, they are independent. So what if xi and xj are independent, then covariance of xi comma xj is going to be 0 when I is different from j, and covariance of xi comma xi, I mean I is equal to j, this is going to be variance xi. So when I say I is equal to 0, you can say here what I've done here, I is equal to j. So when I is equal to j, covariance of xi xj is going to be, you can write it j, covariance of xi xj is variance of xi when I is equal to j. When they are different, there is 0. So I is different from j, then covariance of xi xj is equal to 0. So see here, covariance of x1 x3 is going to be 0, x1 x4 going to 0, like that. So when we collect the term in which covariance xi occurs, so how many terms will like that? So you can see covariance of x3 x3, covariance of x4 x4, like covariance of up to covariance of x98 and x98. So if I write, so we get covariance x3 x3, covariance x4 x4, and it will go like till covariance of x98 x98. So these are the covariances in which I and j are equal. So this is nothing but variance of x3 plus variance of x4, because I and j are equal, up to variance of x98. Each xi has variance 1. So again, it's a x3 to x98. So how many terms are there? 98 minus 2, so 96 terms. So 1 plus 1 up to, it is 96 terms. So 96. So what we got? Covariance of xy, I got 96. Variance I got was 98. Variance of y was also 98. So we need correlation coefficient between xy. So that was formula is covariance xy, it is 96 upon root 98 into root 98. So that is going to be 96 upon 98. Correct? So let me see the option. So yes, option B is 96 upon 98. So option B is correct.